In this lecture, we have to discuss three large topics. First topic, we should discuss probabilities again. We have to learn how to solve a following exercise. Imagine you calculated sample average. For example, average income or average weight or average GPA. And you want to answer to a very simple question. What is the probability that my sample lies between two numbers? One number, another number. What is the probability that my sample lies somewhere here between these two numbers? Pretty simple. Example. I estimated sample average GPA among HEC students, and this average is 7.5. What I know that it is a sample average. I didn't survey all HEC students. I got just a small sample, and hence my sample average is a random number. So another lecturer could get another students to find and this lecturer could calculate a little bit different sample average. Well, and most lecturers can try to answer a simple question. What is the probability that our sample averages lies between 7 and 8? That's it. Next topic is about confidence intervals, and I think that this topic is even more important than finding probabilities using Z tables, because to be honest, we rarely look for probabilities using standard normal distribution tables, but we often calculate confidence intervals. And today we have to learn what confidence intervals are, how to calculate confidence intervals manually, and how to calculate confidence intervals in Stata for sure. Well, and finally, so at the end of our lecture, we should learn more about Stata. We have to learn how to write do files, how to write log files, and how to use if conditions in Stata. If conditions are very important and very useful pieces of syntax that we use in everyday work. I think that's it about our plans for this meeting, and now so it makes sense to start our lecture. So wait. Good. So from the last lecture, I explained that in the last lecture I explained that a good estimator, i.e. the average, should be unbiased, consistent, and efficient. But how can we measure whether our estimator is good? So there are three philosophical concepts: unbiased, consistent, efficient estimator. But statistics isn't philosophy. So statistics is about numbers. And how can we use numbers to explain whether our estimator is good or bad? What does it mean, good estimator or bad estimator? So first of all, we use an indicator, standard error of the mean, to know whether our sample mean is a precise measure of a typical value. Well, sample standard error of the mean, so it could be large, meaning that sample average isn't precise, or if standard error of the mean is small, we can say that sample average is very precise. Again, precise sample average, small standard error. Unprecise sample average, large standard error. Or robustly speaking, so standard error of the mean, it is a measure of some error. When it's a number, right? Number indicating how big our error is. When our number is large, value of standard error is large, we can say that our error of the mean is large, hence mean isn't a very reliable in this research. Well, there are two ways to calculate standard error of the mean in practice. So, and both ways depend whether we know sigma, is whether we know standard deviation. Sometimes we know standard deviation, and in this case we have to divide the known standard deviation by the square root of the sample size. Well, when we can know population standard deviation, now probably you have maybe technical documentation which states that population standard deviation equals certain value. Well, but in practice, especially in management, especially if you work with surveys, you don't know the population standard deviation. If you conduct a survey, you cannot calculate population standard deviation because you work with a sample. And in this case, we replace sigma with S, i.e. we replace population standard deviation with sample standard deviation. And this formula can be found here. Well, and from this moment of time, we are going to use these two formulae a lot because these formulae are used to calculate probabilities that our sample mean lies between two numbers. These formulae are used to calculate confidence intervals and I think that these formulae are used not this formula, but idea behind this formula are used in other statistical concepts and econometrics as well. So what you have to remember from this slide, remember that we need something to measure how reliable our sample mean is. And this measure is standard error of the mean. Larger standard error mean that our sample mean is unprecise indicator. Small sample error of the mean is about good news for us, meaning that so average is a precise indicator, and that's it. Well, okay, imagine that you can calculate samples standard error of the mean. Well, what you have also to remember, don't be confused with standard deviation and standard error of the mean. By the way, it is one of our favorite questions in the exam. Well, so what is the key difference? Standard deviation is a measure of variability. Standard deviation tells how different our values are in a given data set. But standard error of the mean, it's like a measure of quality. It shows how precise our sample average is. So, and yeah, so the difference again is simple. Standard deviation is a measure of variability and sample average. And standard error of the mean is a measure how precise sample average is. That's it. Don't be confused with these two indicators. Well, how can we use standard error of the mean in practice? Well, first, we can use it to recalculate that value. 1 week ago, we learned how to find a probability that a number lies between two numbers. For example, what is the probability that average daily return of a stock lies between 1 and 2%? Or what is the probability that average daily return is positive for a given stock? But we can continue this discussion and try to ask ourselves, well, we know average daily return. For example, it is 1%. We know that average daily return is a sample average. So it's not a population average, hence it is a random number. Hence, if someone get another data set for another period, or maybe so our colleague could use weekly data or monthly data instead. So the sample average could be different in this case, right? Because of sampling process. And we would like to ask ourselves a simple question. Okay, my sample average is 1%, but what is the probability that my sample average is between 0.5 and 1.5%? Right? Or another question, what is, for example, you calculate average income among your clients. For instance, you sell something, say pens, and you have 100 clients, you got a sample of your population. For instance, you surveyed 50 clients and you estimated average income. You know that average income is calculated on the basis of a random sample. Hence, another random sample could give us another sample, another average, and we want to find out what is the probability that sample average lies between, for example, average income lies between 20,000 ruble and 30,000 rubles. We can ask these questions using such a simple formula. Look, this formula looks pretty similar, I think you are familiar with that. So yesterday we reviewed how to use that statistics to find probabilities. And again, in numerator, you have to find a difference between mu and average, some average. But in denominator, there is a difference. Yesterday, we used sigma in denominator, just single sigma. But now we should divide our sigma by the square root of the sample size. Well, and if you do this, you can discuss that given sample, sample average lies between two numbers, or it exceeds a number, or it's smaller than any number. So that's it. Well, how can we use it in practice? Please read this task and type plus if you are ready for discussion. Shall I start? Okay, let's start. Well, again, likewise in previous lecture, my recommendation for you, draw a picture, make a picture, draw distribution and find where population mean should be, where sample mean should be, well, and what area, what probability or what area you are looking for in this exercise. Because if you do this, you will understand, or you will avoid mistakes. Well, first, assumption. In statistics, we work with assumptions. In this exercise, we assume that our variable of interest, highest length, follows a normal distribution. That's important. Well, why we cannot apply the same logic for binary variables? Because binary variables don't follow normal distribution. But if you work with continuous variables, they can follow normal distribution. Well, how to know whether can we know in advance whether our variable follows the normal distribution? Usually, I would say maybe. Well, why maybe? Because in practice, we know that some variables should follow normal distribution. For instance, age, if you make a distribution of age using population data, census data, you will see that it looks more or less like a normal distribution. But some variables doesn't follow normal distribution, especially when these variables are measured using money measures. Everything measured using dollars, rubles, euro usually don't follow normal distribution. Well, how to solve a problem when our data doesn't follow normal distribution is a topic for the next discussion, I think for the next lecture. But now just think, okay, whether my variable is continuous? Yes, no, yes, my variable is continuous. Could this variable follow normal distribution? Yes and no, I think yes, so could be. Well, hence I can apply, so hence I can go further. What we are looking for? We have to find out whether our x, our sample average exceeds this number for 4.1 inches. Well, and if we plot this case, we can find a population average. Population average is always in the middle. When I ask you in a seminar, please don't use that values, use original units of measurement. Draw a distribution and show me where population mean should be. Always, remember, always find a point in the middle and draw a line. Line in the middle is your population mean. Always, that's a rule. Next you have to look on the right side or at the left side to find sample mean. Sample mean for sure could be bigger than population mean and smaller population mean, respectively. In this case, we see that population mean is bigger than sample mean is bigger than the population mean. Hence, we have to look at the right side and draw another line, this one. Next, we have to think what area we are looking for. Are we looking for area on the left side or are we looking for area on the right side? How can we learn it? How can we find out it? We have to look, we have to read this task again and look. And we have to find a keyword, for example, exceeds, exceeding, greater, meaning that we have to use no less operator or bigger operator, well, or small, meaning that we have to look for the left side. We see that mean exceeding 4.1 inches, hence we have to look for this area in our distribution. We have to calculate square of this area in the distribution. But note that standard normal distribution tables gives us squares of areas for this part, for this element, not this one. Hence, we have to do something to get this number. Well, how should we do this? We should apply such a formula. Well, for instance, that is 1 and our job. And if you aren't confident with this exercise, I recommend you to draw another picture using Z values on x-axis. And this picture can show you what area exactly you are looking for. We are looking for this area and we have to find out whether Z exceeds 1. Well, exercise for you. Let's check whether you understand well the previous topic. Tell me please, what is the probability in the chart? Try to use your confidence table, your standard normal distribution table, and tell me the answer. Mm-hmm. Okay. Okay, good. Not bad. Let's wait a couple of minutes when other students publish their solutions. Guys, it's okay if you make mistakes in the lecture because your answers aren't assessed now. Moreover, I think it's better to make it's good to make mistakes in the lecture because in this case I can explain what you have to do to avoid this mistake in future. Well, what have we do to, so what is the solution? So let's do it together. Let's go to our standard normal distribution table, right? And let's find z value. Look, our z value is 0.3413, right? Do you agree? Type plus or minus. Ivan and other students, yeah, thank you for this question. Well, let me make a small comment. Please use tables from our textbook. I know that it is very easy to find tables somewhere in the internet, but tables could be a little bit different, and it will be especially important when we learn student distribution or t-distribution. Well, how is this possible? 8413. That's strange because maximum value in our table cannot exceed 0.5. Maybe in your table the author multiplied all numbers by 2, but anyway, in this case, number should be different. Yeah, for sure. So 0.3413 and solution is 0.5 minus 0.3413. And it will be 0.1587. So this is the right solution to our exercise. Well, not bad. I see that you know how to use that tables, and that's good news for us. Well, now at home you have to practice this exercise a lot. So it's a pretty simple, and again, my recommendation for you, use this exercise to know whether your sample averages lies between certain interval. Well, and by the way, it could be very interesting for you. Probably at home you investigate a data set and study about mutual funds, and it could be very interesting to calculate probabilities that mutual funds could demonstrate positive return. Well, okay, we estimated how to find probabilities that sample average lies between certain interval or exceeds some number or lower same numbers. But in practice, it could be interesting information, this information, but in practice we use another tool. And this tool is confidence interval. Don't read this slide. Let me explain it Well, yeah, Ksenia, let me explain it so without demonstrating my screen. I don't like when students simultaneously read slides and try to listen me. Well, good. Well, what confidence interval is? Oh, it's clear from the name that interval is something about interval. It's something about two numbers. What interval we know from our everyday life? For example, we know that the train arrives between 1 hour clock and 2 hour clock. It is time interval, right? Or we can say that, so for instance, so our speed could be between 70 kilometers per hour to 80 kilometers per hour. Could be another interval. Our income can be between $1,000 and $2,000. So any interval is about two numbers. And when we speak about intervals, for sure we assume that we speak about two numbers. And what else? We have to make a distinction between, we have to distinguish between point estimate and confidence interval estimate or interval estimate. What is the difference between point estimate and interval estimate? Point estimate is always about a single number. One number, point estimate. Two numbers, interval estimate. Well, let me tell you a case from my experience. Several years ago, we gave students a very simple task in a paper-based test. Our task was very simple. Could you please predict your mark for this task, for our test, using interval estimate? Let me type this question in a chat. Could you please predict your mark using an interval estimate? Tell me please, what in the chat, what should, if you were a student, what should you type? Type in the chat. If you were a student, what your answer would be? Other students? You can type any numbers. It's not necessary to use our scale. Okay, very good. Yeah. And by the way, most of students gave us a single number instead. So most of students gave us point estimate. But your answers are right. Well, if we speak about interval estimate, always give us two numbers. Well, how can we find these two numbers? Now let me share my screen to explain how to find them. Well, so in point estimate, everything is simple. Just you can calculate average or median. That's pretty simple exercise, and everyone can do it. With interval estimate, situation is a little bit more complicated. First, when we speak about confidence intervals, we have to speak about probabilities. We are looking for range of values, so lying within the actual. So we are looking for a range of values that should cover our value of a parameter. It is a keyword, parameter. Why it is a keyword? Because we want to find an interval where population average must be in. Again, when we use confidence interval, we are looking for two numbers, our interval that covers our population parameter or population average. That's important. We don't speak about sample averages in this case, in this context. And we have to define, I would say, a measure or indicator of preciseness, or we have to define how precise our interval should be, or a given probability, 1 minus alpha. And let me explain what my 1 minus alpha means. We will speak about this a lot in this course, and I recommend you to make notes now. Well, 1 minus alpha or alpha is a level of significance for the confidence interval. 1 minus alpha is the degree of confidence. Alpha lies within interval between, no, actually something, a number close to 0 to something close to 1. So it is interval for alpha. Oh, for sure, if you take alpha, for example, 0.2, you can calculate easily degree of confidence. But what does it mean, alpha? How to interpret it, and where can we find alpha? First, smaller alpha means higher precision of our confidence interval. Usually, we take 3 possible values of alpha, 0.1 or 0.05 or 0.01. These two numbers are 3 possible values of alpha. For sure, you can set your own alpha. It could be 0.2, but usually we don't use numbers bigger than 0.2. So alpha must be small and as small as possible. Well, what does it mean, alpha? It means that it is it's a probability that you can make a mistake. What does it mean, mistake, in this case? You have 2 numbers, interval, right? You know that your sample is, you know that all of your calculations are made on the basis of some sample. Hence, these 2 numbers are random too. Well, and it could be a case when your population mean lies outside this interval. And probability of this case is alpha. Again, alpha shows probability that population mean is outside the confidence interval. Or, robustly speaking, it shows probability that our confidence interval can tell us a wrong story, or could be wrong. Well, how to define, how to make a choice what alpha to use? We have 3 options. Well, it depends on the task. It's, by the way, a philosophical question, and there is no well-defined algorithm how to find appropriate alpha. When we have to use small alpha, imagine that you check quality of a new safety system for planes or for cars. Well, and your variable of interest is a continuous variable measuring this safety. Well, in this case, you need a high precision of your analysis. Well, in this case, if you test safety systems, you should set really small alpha, or small as possible. But if you test something which isn't very important for us, for example, quality of pencils, well, it's not a serious problem to buy a defeated pencil. You can set larger alpha, but there is a trade-off. When your alpha is small, your confidence interval is going to be narrow. Narrow confidence interval simplifies analysis. When your alpha is large, your confidence interval is going to be really large. Example, imagine you want to invest in a stock and you want to calculate, so you know that average return is a sample average, it's a random number, but you want to find information about population return or true return. You can use confidence interval. You can find two numbers, and in this interval, population return should be in. Okay, you can find two numbers, but you have to define alpha. When your interval is large, for example, your interval could be between 1 minus 1% to 1%. It is unclear whether your return is positive or negative because your population return could be both positive, negative, or even zero. But when your interval is narrow, for example, it lies between 0 and 0.25%, it is clear that, okay, population return lies between 0 and 0.25, hence, so I can get some small positive return, not bad. Well, but what matters here is the level of precision. In the first case, level of precision is high, but it's difficult to make a decision. In the second case, level of precision is low, but it is easy to make a decision. Maybe this discussion is too abstract for you. Let's do exercises to make it so as clear as possible. How to estimate confidence interval. To estimate confidence interval, you have to do three things. First, you should find point estimate. Next, you should find critical value and standard error of the mean. Well, point estimate is sample average. You know how to calculate it. Standard error, we discussed it several minutes ago. What you have to learn how to find critical values. We find critical values using statistical tables. It could be standard normal distribution table or it could be student distribution table. Let's go on. Well, first, two cases. There are two cases when we calculate confidence interval. First case, when we know sigma, highest, when we know population standard deviation. If you have such a case, you are lucky because you should use standard normal distribution tables. They are pretty simple. Well, and you have to, well, use, so you're familiar with that. Well, but what is the difference in contrast to previous exercises? Now you have to divide your alpha by 2. Well, why? Because so your interval is symmetric. You are looking for two parts of the table. Well, in other case, is a little bit more complicated. It is about student statistics or t-statistics, and we use it when sigma is unknown. And by the way, in most of research papers, reports, we rely on the second case because usually we usually don't know sigma. Instead, we calculate sample standard deviation. Well, and in this case, we have to use t-distribution table. Tell me, please, have you ever used t-distribution table in your probability theory course? Plus or minus? Okay. All the students, have you ever used t? Never. Okay, good. That's not a problem. Well, first, if you open your textbook, you can find appendix look, D, it is our standard normal distribution table, and there is a appendix F, values of T for selected probabilities. Well, look, and here we have an example how to use such a table. Well, this table is a little bit different. It has some differences if we compare it with standard normal distribution table first. In standard normal distribution table, we are looking for probabilities. But here, we are looking for t-values. So they are probabilities. No, for sure, they can be probabilities because so maximum number is 2.6, almost 2.6. Well, and we have two interesting pieces here of information. First, we have DF, is degrees of freedom, and we have 3 rows, confidence level, 1 tail, 2 tails. Well, and we have an example. Remember that when we work with confidence interval, we are looking for either this one or either this one. Doesn't matter what. No, usually we work with positive number of t-statistics. Well, how to use such a table? First step, you should find degrees of freedom. What does it mean, degrees of freedom? No, here there is a formula. You can remember such a formula. N minus 1. N is your sample size. 1 is K. Well, what does it mean, degrees of freedom? What is the idea behind this concept? Imagine that you can you have 5 numbers, and let me show you it in Excel. Imagine that you have 5 numbers, 1, 2, 3, 4, 5, and you can calculate the average, right? Well, if you know the average, and if you know any 4 numbers, you can easily find one number in the sample. You can easily find this number. It's not a problem for you. Or if you...
Excuse me, we cannot see your Excel.
Oh, sorry. Wait a second, please. Sorry. Thank you. Yeah, look, what is the idea behind degrees of freedom in this context? Imagine that you have 5 numbers. 1, 2, 3, 4, 5. It's pretty easy to calculate sample average. Well, that's clear. But why we have n minus 1 in this case? Imagine that you know sample average and you know 4 numbers in your sample, but you don't know one number. No one knows what the number is. And in this case, we can say that we lose 1 degree of freedom, n minus 1. Well, by the way, we know 3, but we don't know 4. The same logic can be applied for this case too. That's pretty easy for us. Well, and this is the reason why we use n minus 1. And remember, when you're looking for t-statistics, please first find your sample size -1, and you should find appropriate row. For example, in this note here, the author uses degrees of freedom 10. Hence, it's if the author wants to find confidence interval, his sample size must be 11, but it uses 10. Next, we are looking for alpha. So, and we have two actually rows here we should work with. It is confidence level Well, or we can use alpha, two tails. Don't use one tail now. You should just use the first row or the last row. No, two tails actually are over alphas. Alpha could be 0, 1, 0 0.05, 0 0.01, or even bigger. Well, how to find a table? Well, if we have, for instance, two-tail test, or we have, so confidence interval, you should rely on this column, 0.01 or 0.1. And this is our number. In another example, it could be a little bit tricky exercise. Look, let's do it together. N is 10. Tell me please in the chart, what is our degrees of freedom? N is 10. Right, 9. Very good. Next, imagine that our confidence level is 95%. What is our alpha? Right, 0.05. No. Now we are looking for. Now we have to use our table. So, yeah, our degrees of freedom is 9. And we have to work with this row. And our alpha is 0.05. Let's take this one. And this is our number. Just look at this row and find the right number. 2.2622. What should we do with such a number? How to use such a number? Well, we should apply a simple formula. We should put this number here. Next, we should calculate standard error and point estimate. Once we have all of these three numbers, we should find a difference between average and this element and or add these two numbers. Well, next, what you have to keep in mind when you, or what you have to take into consideration when you work with confidence interval. First, be careful if the population doesn't follow the normal distribution. Well, in this case, your confidence interval cannot tell you a true story. But if your sample size is greater than 30, we can calculate confidence interval and we shouldn't care about distribution. Now, to be honest, your textbook states this. To be honest, I a little bit disagree with the textbook because for sure sample size is 30 is too small. And I would say that if your sample size is large, for example, 1,000 cases or 2,000 cases, you can, anyway, you can calculate confidence interval and you shouldn't care about the form of the distribution. But when your sample size is small, well, you should care about it. What is, so how to find a difference between small and large? So samples, there is no clear solution in statistics. No, my recommendation, if you have probably 1,000 cases, could be fine. Well, Yeah, and the last piece, interpretation. Remember that interpretation of confidence intervals requires knowledge of these two approaches. Approach first, probabilistic interpretation. Well, after repeatedly taking samples of salesperson performance and constructing confidence interval for each sample mean, next you have to say the confidence level of the resulting confidence interval will in the long run include the population mean. My recommendation for you, learn this phrase by heart and replace necessary words with your words. For example, you should replace salesperson's performance with stock market performance or income or marks, so on. Or it could be practical interpretation. We are 90% confidence that the population mean score is between these two numbers. Well, in practice, we use the second approach, but as a student, you have to learn both. And next Monday, we will check whether you know this interpretation. Well, now let's do some exercises in Stata, because for sure you can easily learn how to calculate confidence interval using your textbook or using my lecture notes in theory or manually. But in practice, we never use tables or Excel to calculate confidence intervals. We use programs. Now, everyone, please open Stata. And in Stata, let's open our dataset from the last lecture, L5 data. Please open L5 data. Type plus if you are ready. Okay, good. Let's go on. First, prior calculating confidence interval, I promised you that we have to learn something new in Stata. So let's do this. First, let's learn how to record our actions in Stata or how to record outputs in Stata. To do this, you should write log file. How to write a log file? First, let me show you how to write it. Wait. First, you should set working directory. Let me type in the chat first. Set working directory. To do this, you should click File, and in File, find Change Working Directory. Click Change Working Directory. And choose place where you want to save your output. I prefer my desktop. Okay. Do that. If I have to show it again, indicate somehow. Type plus if you are ready. Good. Next you have to open log file. To open log file, go to File And look, in File tab, you should find log option. And here you should click Begin. Again, go to File, go to Log, click Begin. Again, File, Log, Begin. Well, and set, for example, I want to save my log file here and write its name, my first log. Don't click Save. File type. Well, you can set SMCL, log, or all files. My recommendation, well, for you to set txt. And click Save. If you have such an output, it means that you opened a log file.
Evgeny Alexandrovich, what if on Mac software we don't have such an option?
Let me explain. Yeah, if you don't have such an option, and by the way, let me show you. Yeah, if you successfully opened log file, please type log close. Well, in practice, we usually another way to open log file. We usually, so look, we defined a working directory, and everything we do in state, we can save in this directory. Well, hence we can open log file, we can type log using, and in quotation type file name, for example, my first log, comma, replace. Replace means we use replace if you want to replace the existing file. And use another option T. What does it mean T? T means text. I want to open my log file in my notepad. I don't want to use state to open my log file. To do this, I should use T option. If you are a Mac user, well, yeah, Anastasia, but now I'm explaining how to write log in txt format. Look, and look, log type, text. This is a place where your log is, and it is a time when you opened this log file. Wow. Now
Can I have a
everything.
question? Excuse me, but still, what format should we choose first?
txt.
But on Mac, we need to save it first, or we don't need to save it first.
Do you use manual way? Did you click file, log?
Yeah, I create new log, then everything step by step. But when we chose a file format, we need to choose something first, and then we can replace it with text, as you said.
No. Let me explain it from the very beginning. Look, there are two ways to start log file. First way is manual way. Go to file, click begin, so on. In this way, you have two possible formats, SMCL or log format. Both formats can be opened in Stata. You can open them using Notepad, but file cannot be user-friendly. So it can be hard to read them. Well, at least on PC version. It's better to write log file in txt format. Well, to write log file in txt format, you should use command line. You should type such a piece of code to write your log file in txt. Well, and if you are Mac user, close the existing log file and open log file in txt.
Oh, so these two possible variants of how to create it, right?
Yeah.
Okay, thank you.
Two ways to do the same. Shall I go next?
Evgeny Alexandrovich, I have a question considering the same problem. I do all the steps and open this txt file, and to tell you the truth, this is still saved as log file and not log.txt.
Check. Do you have log type text?
Mm-hmm.
And you opened it and you see that it is still log.
Mm-hmm. I don't see the text after the...
Your file is empty, you mean?
No, there is some things like name, log type, and open on, but in the... В общем, сверху написано my first log, .log, а не .log text.
Oh, you can use here using any name you want without points. Just close your file, log file, and start a new one with maybe more convenient name.
То есть там не должно быть слово текст в самом названии файла?
No, it's not necessary.
Все, спасибо большое.
Sometimes we need it, it's not necessary. No, I will show you what the output should be. Look, we can summarize our data. State records everything. There is another interesting command in state, describe. Describe is used to make a table with variables and their labels, like this. Please use describe command. Next, now what about confidence intervals? To calculate confidence intervals, there are two ways. First way, manual way, you should go to somewhere, click something, and do something. Another way, we can use command line. We have to type something like that and so on. Let's learn both ways. Way number one, manual way. No, way number zero, help. Help, and instead we use a command CI to make a confidence interval. This is help file for our confidence intervals. You can read so PDF manual or manual here. Well, and what we have here in menu, we have a root for confidence intervals. This is the root how to calculate confidence interval manually. Look, statistics, summary tables. Well, follow this route to open a separate window for confidence interval. Summaries, tables and tests, summary and descriptive statistics, and look, we have confidence intervals option. Open this window, please. By the way, do you see my window?
No,
I guess
I
we don't
see.
because you are sharing only this
Oh.
data.
Wait. Yeah, look. You have such a window. Let's get it in. Ready? Now let's do it together. First, we are communicating with data, with a program, and we have to tell program what it has to do. First, tell Stata what it should calculate. Confidence interval for the mean, for the proportion, for variance, and standard deviation. And by this moment of time, we learned just confidence interval for the mean of the mean. Set first option. No, by default, Stata chooses this one. Next, what variable you want to use to calculate confidence interval? Let's choose this one. confidence interval type normal. Yeah, as usual. Well, and use confidence level, it could be 95, 90, 99, let's set 95. Click submit. What we have here, look, we have sample size, we have mean, standard error. We discussed it today, right? And confidence interval. So population mean lies inside this interval with 95% of confidence. Well, another way to calculate confidence interval is about, let me show you, normal mean. Yeah, not this one. So yeah, that's it. And how to interpret such a number? Well, we can say that we are 95% confidence that the population mean score is between this number and this number for sales in region 3. Something like that. What else? In addition to go to help file. In help file, you have a lot of options. Well, for example, if you click here, you can find that you can set level. What does it mean, level? It is your confidence level. Well, separator and total. Well, we have to use option level. What else? In addition to this option, we have another set of options. Exact, Walt, Wilson, Agresti, Jeffries. What these options are. To be honest, we learned just to think one way of confidence interval estimation. There are different ways. And if you replicate this exercise in Excel for the same data, you will find that your confidence interval is different from this one. If you check everything still, and you see that everything is correct, still your confidence interval will be different. What's the problem? Stata uses exact way of calculate confidence interval estimation, but your textbook uses WALT. Wait. Yeah, CII maths. That's strange. Not here, yeah. Just use it as this interval. But yeah, what you have to keep in mind that sometimes intervals could be different because data uses a little bit different algorithms, can use a little bit different algorithms, and we don't discuss these algorithms in this course. How to customize this option with option level? Use any confidence level, for example, 90 or 99 to recalculate the same confidence interval. And let me illustrate a concept of confidence level in this case. Look, I use a small confidence level, and this range is small. This range is, so my confidence interval is pretty narrow. If I use large confidence interval, my range is going pretty large. Well, when you want to estimate, for example, confidence interval of the return for a store, what you have to think about this problem that sometimes setting small alpha gives us so useless information. And there is always trade-off between how narrow our confidence interval should be and how precise our analysis should be. and how to solve such a problem. There is no single solution. Its solution is your arguments. You should explain why you use such an alpha, and next you should go on with your analysis. That's it. Questions? Okay, one piece of information more. In Stata, we often calculate descriptive statistics, and often we need to use if statements. For example, I want to estimate average value of my variable if my variable is bigger than 5. And Stata recalculates sample statistics and look mean is different. Well, you have to work with if statement a lot in Stata. So you can use bigger, smaller, so no less, no bigger, or equal. If you use equal, please always set double equal equal. Use equality always. Well, next, now imagine that we calculated all of this stuff and we want to save our work. How to save our work? First, select all commands from your command line. Select all your commands in your command line and click this one and use send select to the do file editor. Let's do that. Should I show it again?
Yes, please.
Yeah, what you have to do, especially for Mac users, please find a button, this one, you do file editor. Click it. If you click it, Stata should open a new window like this. It looks like a notepad. Do you have it?
Yeah.
Good. Next, copy your comments. Just copy your comments and paste them to this do file editor. Look, here we have comments you used. If you want to comment something, use asterisks. Open log file, for example, or open help, and so on. Stata uses blue color to indicate a command name. Stata use black color to stress variable names, options, all those the rest information. Well,
can you please repeat all the steps for
yeah.
open data editor?
Yeah. Look, on your main tab, you should find such a small button. Its name is New Do File Editor. Successful?
Yes.
Now, select all commands from your command line. Now, copy and paste to your do file editor as usual. Ready?
You select them with Shift button or what way?
Shift, yeah. Or you can click Ctrl A if you have PC. Ctrl A, Ctrl C to copy and Ctrl D to paste. Next, save your do file as a separate file. Go to File, Save As. So save this file as usual, like my first do, and click Save. First thing you have to do. Next, please save your do file. Next, close your log file, log close. Type log close to close your log file. And let me show you what happens. Look, here I have my log files, for example, my first log or this one. Well, I can open my first log file. So this is as SMCL format. It's not user friendly. We have some brackets, so it's not user friendly. But if I open my log file written in TXT, so look, I can observe a pretty useful, so user-friendly report. Here I have the commands that we used, the outputs, commands, outputs, and so on. Well, but if you want to save your work in Stata, you can use log files and do files. Well, I think that's it for today. I suppose you are tired with such, so because we learned a lot of new information. If you have any questions or something doesn't work in Stata, please tell me right now. And other students, small feedback, tell me please, what have you learned in Stata today? What have you learned in the chat, please?